हेलो। मैं ओपी श्रीवास्तव इस वीडियो में पार्शियल डिफरेंशिएशन के बारे में बताने जा रहा हूँ। Myself ओपी श्रीवास्तव just going to explain about partial differentiation in this video. In fact, on screen I have already mentioned about partial differentiation, but let us start from very beginning. Okay, so let us off all this time off it. The introduction. What is partial differentiation? You must have read if the value of y depends on value of x, then we say that y is a function of x. One special thing is there, if y totally depends on x, then y is known as total dependent on x. And we get dy dx means rate of change of y with respect to x. It is one way called total differentiation of y with respect to x. A very simple example of this is that suppose you are on the railway station, you are going to take a ticket. The distance of journey depends on the money given by you. You can change money, the distance of journey will be changed. So you can say that distance of journey is directly depending on the money you give. So money is a independent variable while distance is a dependent variable. Similarly, on the other hand, suppose there is a variable z which does not depends only on one variable, but it depends on two variables x and y both. It may be more also, but for simplicity let us start from two variable only. In real life you can compare it as, suppose you are taking ticket on railway platform. So your comfort depends two things. First, the class you choose. Second, the mode of journey you choose. Suppose you choose mode of journey as train and class as first, then you will get more comfortable. If you stay second class but mode of train is and the mode of journey is train, then there will be a little bit problem with you. It means that comfort depends on the class you choose and mode of conveyance you choose. So mode of conveyance and class basically functions variable, and comfort is also variable, but comfort depends on these two. Okay, these two, I mean class of the journey and mode of conveyance, they both are independent variable while comfort is a dependent variable, and so on. So suppose z is a function of two variable x and y, then only this partial differentiation come in existence. Now, if z is a function of x and y, then del z del x, I mean del z upon del x is called derivative of z with respect to x, y, while y is kept constant. Similarly, del z del y is partial derivative of z with respect to y, while x is kept constant. One more option is there. Suppose z is function of x and y is itself a function of x. As z is function of x, y is function of x, means z is function of x and phi x, means z is totally function of x. In that case, we can get total derivative of z with respect to x. Means we can get dz dx, that will be equal to del z del x plus del z del y into dy dx. Alright, I will discuss lot of questions based on this, then it will be more clear. Now, on the other hand, you can generalize this. Suppose z is a variable which depends on so many independent variables, say x1, x2, x3, x4, xn, like that. And then z is called function of x1, x2, x3, x4 up to xn. Here it is. In that case, del z upon del x, I mean del z del x is known as partial derivative of z with respect to x1 while other variables are kept constant. Similarly, del z del x is partial derivative of z with respect to x while other variables are kept constant. Del z del 3 is the partial derivative of z with respect to x3 while other are kept constant. And similar with del z del xn is the partial derivative of z with respect to x n while other variables are kept constant. So let us see one example also. Here is an example. Z is equal to function of xy. Del z del x is partial derivative of z with respect to x while y is kept constant. Del z del y is the partial derivative of z with respect to y while x is kept constant. Okay, let us do a numericals out of it. Suppose z is equal to x square y cube and you have to find out del x and del z del y. Now del z del x is equal to del x square y cube upon del x. Keeping y is constant, then we will get 2x y cube. And del z del y similarly we will get 3y square differentiation of y while x is constant, so 3x square y. Okay. Another hand, if z is function of xy and y is itself a function of x, then z is a total function of x. In that case, dz dx is equal to del z del x plus del z del y dz dx. So, how it can be done? I am a little bit mistaken here. It should be dy dx. So I am just uh, making it correct. ठीक है? dz dx is equal to what I have written again. So I am making it correct. Example here I have solution uh, again. So where is that? I am just getting it. Just a minute. Just a minute. So del z del x is equal to del z del y into it is dy dx. In fact, it is dy dx. All right. Okay. All right. So what I tell you, del z dz dx is equal to del z del x plus del z del y into dy dx. Now I am going to find out dz dx by two way, by this formula and direct also. So now here first del z del x will obviously y is constant, so it will become 2x y cube and del z del y will become 3x square y square and dy dx as y is equal to 3x power the 4 become 12x cube. Now putting the value in dz dx, dz dx is del z del x plus del z del y plus into dz dx is equal to 2xy cube plus 3x square y into 12x cube. That all finally comes equal to 378x cube. Now directly if you want to do, put the value of y here. So that become dz dx equal to dx square into 3x power the 4 whole cube means d dx is equal to 27x power the 14, that becomes 378 x power the 13. Okay. This way you can understand what is partial differentiation. Very clear. If z is a function of two variable or more than two, then del z del x is the derivative of z with respect to x keeping other as constant and so on. Alright. One very important theorem which is used in partial derivatives, out of which several questions are asked, is known as Euler's theorem. What is that? Let us explain. Euler's theorem, Euler's law or Euler's whatever it is. If z is equal to say function of xy and is a homogeneous of function xy say degree n, then x del z del x plus y del z del y is equal to n into z. It is the Euler's law, Euler's theorem. For example z is equal to say x cube plus y cube upon x plus y. Obviously z is a function of homogeneous function and of degree 2. So let us find out del z del x. न्यूमरेटर का होगा 3x² इंटू एक्स प्लस वाई माइनस एक्स क्यू प्लस वाई क्यूब डिनोमिनेटर का डिफरेंशिएशन 1 हो जाएगा. When you simplify it, you will get 2x square minus y square plus xy upon x plus y. It will, I am sorry, it is a whole square. Again, I have to correct it. I have to correct it del z del y. Oh, in fact, it is del z del y is equal to x plus y whole. That is okay. Del z del y is equal to, after doing this, denominator into differences of denominator, all this come finally equal to 2y square minus x square plus xy upon x plus y whole square. Now x times del z del x plus y times del z del y is equal to x into value of del z del x plus y into value of del z del y. You solve it, finally you will get x times del z del x plus y times del z del y is equal to 2x cube plus 2y cube upon x plus y whole square. In fact, sorry, x plus y. 1x plus y will go away. So that gives you uh, is equal to 2z. Finally, you get 2z. All right. So this way you can prove the Euler's theorem. Again, I explain Euler's theorem only says that if z is a homogeneous function of xy of degree n, then x times del z del x plus y times del z del y is equal to n times z. Here is the proof of it, or it is a proof of it here. One mistake is been done here that has to be clarified. Okay, uh, I'm just edit कर देता हूँ इसको. Okay, there was a mistake in fact. All right. Now let us discuss some formal question based on this. So let us discuss question number 1. Suppose u is equal to log x square plus y square upon x plus y. Prove that x into del u del x plus y into del u del z is equal to 1. कैसे करेंगे इसको? थोड़ा मॉडिफिकेशन देखिए इसका. आंसर कैसे किया हमने? u is equal to log x square plus y square upon x plus y. So let us z is equal to e power the, then automatically it become x square taking antilog of this, you will get it. So e power the is equal to x square plus y square upon x plus y. Now it is very clear z is a homogeneous function of degree 1. 2 is power numerator and denominator has power 1. So finally its degree will become 1. So z is a homogeneous function of 1. So now according to Euler's law, what will be here? X times del z del x plus y times del z del y is equal to degree means 1 into function is z, 1 into z. But z is equal to e power u, so it finally becomes e power u. Now let us find out del z del x from this expression. So del z del x will become e power u del x and del z del y become e power u del y. So x into del z del x plus y del z del y is equal to x into e power u del x plus y into e power u del y is equal to e power u. E power u goes away. So x del u del x plus y del y is equal to 1. Now it is proved. Alright. Now say some other question now. Question number 2. U is equal to cot inverse x plus y upon a root x plus root y. Then prove that x del u del x plus y del u del y प्लस 1/4 साइन 2u इज इक्वल टू 0. ठीक है, आंसर देखते हैं कैसे निकाला गया है. आंसर z is equal to cot u, then that will become x plus y upon root x plus y. Obviously z is a homogeneous function of degree 1 by 2. So x times del z del x plus y times del z del y is equal to half times z according to Euler's law. But z is equal to cot u, so it is half cot u. Now let us find out del z del x from this expression. Del z del x is equal to minus cosec square del u del y. Del z del y is equal to minus cosec square del u del y. So from equation number 2, putting the value of del z del x, you will get minus x into cosec square del u del x plus minus y into cosec square u del y is equal to 1 by 2, z is equal to 1 by 2 cot u. So x times del u del x plus y times del u del x is equal to minus half times cot u upon cosec square u. When you solve it, you will get 1 by 4 sine 2u. So x del u del x plus y del u del y plus 1 by 4 sine 2u is equal to 0. Right? And the problem. Question number 2. It is a little bit big problem. I have taken two part to solve. U is equal to tan inverse x cube plus y cube upon x minus y. Then prove that x del u del x plus y del u del y is equal to sine 2u and x square del square u del x square plus 2xy del square u del x del y plus y square del square u del y square is equal to 1 minus 4 sin square u into sin 2u. आंसर कैसा होगा देखा जाए भाई. आंसर हमने यूं किया है. Now z is equal to, let z is equal to tan u, so then obviously z will become x cube plus y cube upon x minus y. And it is very clear z is a now 2 degree homogeneous expression of x and y. Right? Now differentiate, you get del z del x is equal to, from this sec square u del u del x del z del y is equal to sec square u del u del y del square z del x del y. Right? So differentiate this expression with respect to x, you will get sec square u del x del y plus 2 sec square u tan u del u del x del u del y is equal to sec square u del x del y plus sin 2u. 2 sec square u tan u gives sin 2u del u del x plus del u del y. Similarly, del square z del x square gives you sec square u del x square plus sin 2u del u del x whole square and del square z del y square is equal to, after solving, in fact it is product of two function, so apply the law of product of two function, differentiate with respect to y, we'll get the sec square u del y square plus sin 2u del u del y ka whole square. Now from first, z is a function of, say z is a function of a homogeneous function of degree 2. Now x times del z del x plus y times del z del y is equal to 2z, I mean 2 tan u, but you put the value of del z del x and del z del y, this all becomes x into sec square u del x plus y sec square u del u del y about 2z about 2 tan u. You solve it, finally you will get x times del u del x plus y times del u del y is equal to 2 tan u cos square, that gives you sin 2u. Right? Now this another x square del square z del x square plus 2xy del x square z del xy plus y square del square z del y square is equal to n into n minus 1 into z according to the Euler's law, where xy is a homogeneous function of x, then this expression comes out. So here n is 2, so 2 into 2 minus 1 into z about 2 tan u हो जाएगा. Now whatever the value we have already calculated, let us put it here now. In expression x square del square z square plus 2xy del square z del x del y plus y square del square z del y square x square into sec square del x square plus sin 2 del u del x whole square plus 2xy sec square u del square u del x del y plus sine 2u del u del x into del u del y plus y square into sec square u del y square plus sine 2 del u del y whole square is equal to 2 tan u. Go on solving like this. You will finally get x square del square u del xy del x square plus 2xy del square u del x del y plus y square u del square u del y square is equal to 1 minus 4 sine square u sine 2u. Here this solution go on. See it and do it yourself. Very peacefully you will get on the. Let us discuss another type of question also. If z is equal to function of x plus ay and phi plus phi function phi x minus ay, then prove that del square z del y square is equal to a square del square z del x square. Answer C. Very simple. As z is equal to function x plus ay plus phi function x minus ay. So del z del x will become f dash x plus ay. Differentiate it with respect to x. You will get this one. And with respect to x, that will give you phi dash x minus ay. Del z del y, with differentiating this with respect to a, will get a into f dash x plus ay. इसका हो जाएगा minus a into phi dash x minus ay. Now del square z del x square is equal to f double dash x plus ay phi double dash x minus ay, and del square z del square become a square f double dash x plus ay minus a extra और आएगा तो that will become minus a square phi double dash x minus ay, यानी कि a square bracket में phi double dash x plus ay phi psi double dash x minus ay, and del square z del y square del square z del x square is equal to this much. So putting this value here, you will get del square z del y square is equal to a square del a square del square z del x square. This way you can understand. You see 2 and 3 times, you will very everything is clear. Even then, if it is not clear, you please give me your letter. Our mail address is there. omrds at the rate of gmail.com. Whatever problem you have, put it and make a uh, PDF of it and mail me. I will solve it and I will give answer. If possible, I will make a video also. Feel free to ask any problem anyway, anytime. Just mail me. Okay. Thank you for watching the video. Thank you. I have lot of video also on the YouTube. Go through. You will get lot of things there also. Even then, if you want something new, please give me a letter, give me a mail. I will make that. Okay. Thank you.